Hello everyone. So this session we will discuss about Delta AC server drive PR mode, and this one just the basic part. So first portion we'll talk about which server drive will support PR mode. So here you can see we have A2, A2R, M, S, and A3, P3. So here you can find for different series will provide different PR paths quantity and we'll use different software, but today we'll focus on A3 and B3. Then how to use PR mode. So basically for the control mode, P1 -01 or P1 dot 001. Here we must set to PR mode. And here you can find the definition of each digit. So you can find the definition here for X, Y, Z, and U. X1 means the control mode, so you can find here 01 is PR mode. And because we can change direction and DIO definition, so it will have a different combination. As you can see from the red dot here, so this one, if we modify the value, so we need to reboot the server drive. Okay, then we'll go to acceleration, deceleration, and delay time and speed. So here is the relative parameters. As you see here, for A2, A2R series, we have a 63 PR, and A3, P3, we have 99. So all these PR pairs will share this 16 acceleration, deceleration time, and delay time, and the speed. Okay, so here is a simple mapping. Just let you know each PR will map to which PR pairs property and PR pairs data. So you can find for the command mode the type in P60, P602, 04 until P798. We will have a spin mode, single positioning, auto positioning jump, right parameters, index, and the statement. But statement, this one is only for A3 series. Okay, so PR0 means the homing mode. So if for function test or system without any sensor or limited switch, then you can select the mode 4, 5, and 8. 4, 5 means search the Z-phase of motor, and mode 8 means use current position as home. Okay, then here we'll mention how to trigger PR. So here we provide 3 methods. First one is a standard trigger. That means we use this IO define like a bit 0, bit 1, bit 2, and event trigger. So you can find the event trigger here. And different trigger will use a different parameter to set. And the final one is for use communication, means we can use Modbus or can open. So if we use can open, we need to Modbus or can open, we must define the node ID, means the station address of the device. And this one is define the speed, baud rate, then define the protocol for Modbus like 7E1. Okay, then the final parameter is for the PR trigger. Okay. Before trigger PR, we must enable servo on DI, means like a DI1 here. Otherwise, it will show another message to remind you must do the servo on. Okay, so here we'll show the IO trigger. So you can see first one we use the bit 0. So the sequence is we give signal to bit 0 on. Then we give the command trigger signal. So it will run PR page 1. Another, if we give a signal to bit 1 on, means DI3 on, then we give command trigger, then you will run PR2. Then if we give both bit 0, bit 1 on, then you will we trigger command trigger. I mean DI3, DI5, then it will execute PR3. Then use event trigger would be a more easier way. So you can see this one we need to define in PR pass 51 to 63. But this one we need to define in PR, parameter P5-98 and 99. And here is a example of if we want to use a Modbus trigger. Okay, again here you will see the red dots. That means you must reboot the drive, and we can define the speed in Modbus serial or the CAN bus. And here is for the protocol for Modbus. And this one is for the Modbus address for the drive. So if we want to use Modbus to trigger PR pass 1, so in laptop we can use Modbus protocol to control servo. So this one, just for example, we define the address as 1, station number, and this one is the port rate and the protocol at none to RTU mode. Then we use the function called 6 to write. So this one, if we send this command, 01 means the station number, 06 means the function code, 050E is the Modbus address of the servo drive. I mean this P507. Then we write 001. This one means the PR pass. Okay, and maybe someone will consider this one is too difficult, so maybe you can consider use HMI to control servo PR. It would be much easier. Okay, and regarding the connection cable from laptop to our servo drive, we use USB to mini USB, but here we would strongly recommend you must use this adapter. Okay, so we go to the software portion. Okay, here we select the B3 series and select add drive. And then you pump out this device information, so you just press read servo information. So here you will find the servo model, include the servo barcode. This one is a serial number, so it's quite convenient for customer. And you will also find the motor we connect and its barcode. Okay. And we press read parameter from servo drive. As we mentioned earlier, we go to the P101 for the control mode. So we double click it. So you can see now we already define in PR mode. Okay, then we go to P3. So this one is for the address, station number, and the protocol. Sorry, port rate. And finally, this one is for protocol. We do this because we already set this value, so no need to reboot the drive. Okay, then we will go to the PR mode setting. So we go to the project tree function list, then press the PR mode setting. So here first we will introduce about how to do the homing. So as I mentioned, because now we don't connect any sensor, so we can select mod 4, 5, and 8. So here we use a mod 4 in forward to find the Z index, and you can define the acceleration and deceleration time as well. Okay, and because this one is basically for PR0, so later we will show two way to control. So first we go to the digital I/O, and as I mentioned earlier, we must do servo on in advance. So we do servo on first, and because PR0 means all the combination should be 0, so we just use this one and give a command trigger. And before we trigger the command, we go to scope. On the scope, we can check the feedback position, command position, and if the value are bigger than 16 bits, so you can click here to change the data to 32 bit. If you unselect this one, then the data will be 16 bit. Okay, and you can also define the speed. And here we will use P57 to check the PR. And we can also monitor the DI/IO status. Okay, so we click one and go back to here and trigger PR. Okay, so here you can find this one for the DI. Double click, so it will show each digit. Here you will see for the DI4 means in DI5 is a command trigger in our from our software. Okay, so once we press, you will see P5 7 will be remain 0 because now we execute on PR0. But once it's done, when homing process done, you will see P5 7 will become 20,000. Okay, and you can also find the feedback because it try to find the Z phase, so it will rotate and suddenly go to the value near 0. Okay, so this one means homing process already done. Okay, then we will go to another show another PR mode. So maybe like a PR1, we select speed control, and just remind you for the unit is 0.1 RPM. Okay, so for example, if here we use 6,000 means later servo will run 600 RPM. And this time we will show with Modbus to trigger PR pass. Okay, so as we mentioned, this one is the address. Then for the serial port, we connect with software. Then this is the baud rate and function call. This one is the Modbus address of servo drive, and we want to trigger PR1, so here we give 1. Okay, this one because now we already opened Astasol, so we must start Astasol first. Okay, so here we send the command. And okay, let's go back and check the scope. So here we'll see the speed will keep around 600 RPM. And now it's because it's constant speed, so you will see this one was value will be 10,001. 10,000 means it's still under process. And if you see 2,000 sorry 20,001, that means this PR already done, and you will see this one continue increase because now we let servo work in constant speed mode. Okay, so let's check the scope again. You'll find the scope seems quite messy, so we can select the item one by one. Okay, here. Okay, so you will find here is for the command position and feedback position. So we can enlarge to check the following between command. Okay, so you can see it's almost attached. I mean feedback almost attached to feedback. Feedback almost attached to command. Then we select this one and go to speed. We show again. So it seems so we can enlarge and go to check again what's happening for the speed control. Okay, so you will find for the speed have a slightly difference, 1 RPM difference, sometimes 599. Then let's go to PR. This one will remain the same value. Okay. Okay, then you may concern then how can we do the position control? Okay, so let's go back to our parameter setting first. So position control we are related to electronic gear ratio. So we need go to check here. Uh, 44 and 45 in group 1. So here you can see this one is the electronic gear ratio. So you will find 100,000 here. So this one means we give our 100,000 command, then servo motor will rotate one turn. Okay, so let's go back to PR mode setting. In PR2, let's select a point to point command. This one means just a single positioning. So if we want to do multi-positioning, you need to select a tree. Okay, but because now we just show the basic portion, so here we use this one. And okay, as we just mentioned, we want to let motor rotate one turn. So we should give 100,000 here. And you can define the acceleration, deceleration time. You can assign different value, and if we use think this value is still too big, so you can go back to here and do some modification. Then we select the speed. So for example, now we want one 1000 RPM. So we select 1000, then download. Okay. Okay. Then here is our for PR2. So let's go back here. Sorry, we enable the scope function first. Then we use IO to trigger because PR2, so we need give bit 1 uh, first. Then we give command trigger. Okay. Sorry, my bad. Because I forgot. I need to homing first. So let's stop the scope and sorry, run scope again. Then here we must trigger. Sorry, we off. Then because now is we want to do homing means PR0, so we should keep bit 0, 1, 2 off. Then we give command trigger, so it will execute PR0. And after this, we off command trigger and force signal bit 1 on, then it will run PR2. Okay, so we go back to scope and check here. Okay, so here we will find for the commanded position and feedback is nearly zero. It's 247, 246. This one because it's fine defect, so it will not be exactly zero. And then after we trigger, so you can see the command is 100,000. But you will find the relative value is not 100,000 because we must deduct 247. And here you will find because the speed is nearly 1,000, but because the path is quite short, so it will not go to 1,000 RPM. And here you can see for P57, when the process done, it will become 20,002. Okay, so if we keep command here, and once it done, become 2,000, 20,002. Okay, then that's all for this section. So I hope this video can help you understand more about our Delta Servo PR mode. Thank you.